How and when did our universe begin? How did it get to look like this? How will it end? Humans have been discussing these questions for as long as they've been around, without ever reaching much agreement. Today, cosmologists are working hard to find the answers. But how can anyone hope to find concrete answers to such profound questions? And how is it possible to explore and study something as huge as the universe, most of which we'll never be able to reach? The answer is light, and although light from distant parts of the universe can take billions of years to reach us, it carries 6 unique messages that, when put together, can disclose an amazing amount of information to astronomers who know how to look for it. Just as sunlight can be split up into the familiar rainbow, splitting the light from distant objects exposes different patterns of colors depending on its source. This distinctive light barcode can reveal not only an object's composition, but also the temperature and pressure of its constituent parts. There's even more we can discover from light. If you've ever stood on a train platform, you might have noticed that the train sounds different depending on its direction, with the pitch ascending when it approaches you and descending when it speeds away. But this isn't because the train conductor is practicing for a second career. Rather, it's because of something called the Doppler effect, where sound waves generated by an approaching object are compressed, while those from a receding object are stretched. But what has this to do with astronomy? Sound does not travel through a vacuum. In space, no one can hear you scream. But the same Doppler effect applies to light whose source is moving at exceptional speed. If it's moving towards us, the shorter wavelength will make the light appear to be bluer, while light from a source that's moving away will have a longer wavelength, shifting towards red. So by analyzing the color pattern and the Doppler shift of the light from any object observed with a telescope, we can learn what it's made of, how hot it is, and how much pressure it's under, as well as whether it's moving, in what direction, and how fast. And these 6 measurements, like 6 points of light, reveal the history of the universe.